Okay, for lab 3, we need to go on to phase 2. If you've seen the lab questions, you'll see that they are asking about absolute uncertainties and relative uncertainties and doing calculations with those. So again, the lab error analysis pages and the error analysis worksheet can help with that. So what do we mean by absolute uncertainty and relative uncertainty? Absolute uncertainty is the actual uncertainty that you have. So if you've measured a 125 centimeter shelf with a ruler that has an uncertainty of 1 centimeter, then that is the absolute uncertainty. The absolute uncertainty has the same units as your measurement. Sort of like on a test. So quiz, let's say you missed 5 points. That 5 points would be the absolute error that you have. You've missed 5 points. So 5 points out of a 10-point quiz is a different story from 5 points out of a 50-point quiz or 5 points out of a 100-point quiz. So sometimes instead of points, we talk about relative to the total amount of the quiz, then what is your error that you have. So 5 point out of a 10-point quiz would be 0.5 off the edge of the paper here. 0.5 or 50%. So a lot of times the relative error that you have is expressed as a percent because then it's easier to compare to other things. So let me put that would be a percent. So we no longer have the units, the percent, the centimeters, we have percent. All right, let's take a look at adding some numbers using the significant digits way, the phase 1 way of dealing with uncertainty. So if we have two measurements, 125 centimeters and 62 centimeters, and we're adding them together, again, that last digit is the uncertain digit, so we know the 125 centimeters to the ones place, and we know the 62 centimeters to the ones place, and so we add them together, we would get a result of 187 centimeters to the ones place, and we're implying by writing it like that it's plus or minus 1 centimeter. That last digit, the 7, is the one that's uncertain, and we're saying that it's off. Could be a 186 or it could be a 188. If you think about it a little more closely here, let's say that this is representing a shelf that's 125 centimeters long, and it could be plus or minus 1 centimeter. And then you are putting another shelf next to it that's 62 centimeters plus or minus 1 centimeter. So what kind of range could you get in your results? So if the 125 were really a 124 and the 62 were really a 61, you could get a number as small as 185 centimeters for your total length. If on the other hand, your real length is 126 centimeters, a little bit longer, and 63 centimeters, you could get something that's as large as 189. So if you happen to measure both a little bit longer than they are, they're actually shorter. It could be 185. Otherwise, it could be 189 if you go the other direction. So this range, instead of 187 plus or minus 1, the uncertainty of 1 and 1 add together to give a total uncertainty of 2, 187 plus or minus 2, because it could be as short as 185 or as long as 189. Just a quick note here, even if you're subtracting numbers, those uncertainties are going to add. So if you were subtracting the numbers, It's not that you would get the 125 plus or minus 1 centimeter minus 62 plus or minus 1 centimeter. So you would not get 63 plus or minus 0 centimeters. So you don't subtract it. So they also add. It would not be 63 plus or minus 0. It would be 63 plus or minus 2 centimeters. You would also add even if you were doing subtraction. So it's still, the order of magnitude is still in the ones place. So your error has not changed from 1 centimeter to 100 centimeters or 10 centimeters. It's still in that ones place. It's just that instead of 1 centimeter, it's actually a little bit bigger. It's actually 2 centimeters. All right, let's take a look at multiplying or dividing some measurements. In this example, we have a piece of paper and we've measured 11.0 centimeters and 19.9 centimeters, similar to what we were doing in Lab 1. So the significant digit way that we used in Lab 1 was to say, okay, if we measured with that 1 centimeter ruler, we have 11.0 and 19.9. They each have 3 significant digits and they have uncertainty in the 0.1 place. 0.1 centimeters uncertainty. Then when we multiply these together, we get 218.9, but then we round that to 3 significant digits and we get 219 square centimeters. So this is implying that we have uncertainty in the ones place. And we were talking about this as being plus or minus 1 centimeter squared. But if we look at this a little bit more closely, 11.0 centimeters plus or minus 0.1 centimeter means that you could have something as small as 10.9 centimeters or something as large as 11.1 centimeters. Similarly, 19.9 plus or minus 0.1 centimeters means that the length or the width could be as short as 19.8 centimeters or as long as 20.0 centimeters. So if both of our numbers should have been smaller, our area would be about 216 centimeters squared. I'll go ahead and round that to 3 significant digits. Or if they were both larger, you would get 222 centimeters squared. So the range, instead of being from 218 to 220, as would be implied by this, actually the range could be from 216 to 222 square centimeters for your area. And that is a 6 square centimeter range. And so if you divide that in half, you get a plus or minus 3 centimeters. So 219 plus or minus 3 square centimeters could be as small as 216 square centimeters or as large as 222 square centimeters. So if you didn't want to do both of these different multiplications, let's get a different color. If you didn't want to do both of these every time and say what would the small ones give me and what would the large ones give me, we want a way to just look at these errors and figure out what the final error is going to be. And it's not obvious, not like up above when we would add the 0.1 and 0.1, that would only give us 0.2. We certainly can't multiply 0.1 and 0.1 because that would give us 0.01 square centimeters, and that's not what we want. We want something that's going to give us the 3 square centimeter error. So that doesn't make sense if we are counting or looking at the 0.1 centimeter in the measurement, the absolute error, but it does make more sense if we use the relative uncertainty. So 0.1 centimeters over 11 centimeters. We'll take that and then we'll get that as a percent. So that actually equals 0.009 or 0.9%. So that's where that percentage comes from. 0.1 centimeters over 19.9 centimeters is actually 0.005, and then when we write that as a percent, it becomes 0.5%. So even though both of those uncertainties are the same, absolutely, the absolute uncertainty is 0.1 centimeters for both, then with the longer measurement of 19.9, it's actually a smaller percentage. Just like missing 5 points on a 50-point quiz is not as big a percentage as missing 5 points on a 10-point quiz. So we have different relative percentages. Then when we add the relative percentages, let's get this going here. So if we add the 0.9% and the 0.5%, that comes out to be 1.4%. So what is 1.4% of the 219 square centimeters? We need centimeters squared here. So what is that? So that is same as 0.014 times 219 square centimeters, which comes out to be approximately 3 square centimeters. So that's what we had just figured out on the previous page, the 3 square centimeters. So that's where that comes from.